Esteemed viewers, in this tutorial we clearly discuss the Go-Back-N and Selective Repeat protocols. This comes as a sequence for tutorial number 2, wherein we discussed the automatic repeat request protocols in different versions, and the last protocol in that series was RDT 3.0. We may recall that RDT 3.0 was a robust protocol as far as reliability issues are concerned. However, it suffered from a damage. The damage was it was ARQ protocol. ARQ protocol, as we may recall again, will send a packet, and until the acknowledgement for the packet that is being sent is received, the next packet will not be sent. Therefore, the channel used to be idle for long durations. This also caused ineffective use of channels. So that is the reason why two protocols, which were robust protocols, were identified or invented. One is Go-Back-N protocol, the other one is Selection Repeat protocol. These two protocols are pipelined RDT protocols. Both the protocols will have the blessings of all the reliability related services that is being provided to the byte stream flow. However, they have succinct difference between them, and as we go on discussing both the protocols, the things will become clear. Okay, we will be increasingly understanding the working of Go-Back-N as well as the working of SR protocol. Go-Back-N is a pipelined RDT protocol, and a pipelined RDT protocol can be visualized something like this. Here is the sender and here is the receiver. This is the first packet that is being sent. Before the first packet reaches over here, and before the acknowledgement is received by the sender again, many packets are pumped into the channel, thereby effectively utilizing the channel bandwidth. It promised efficient use of bandwidth of channels apart from providing reliability based services. GBN sender possesses a window because the pipelining of packets necessitated several packets to be pumped into the channel. These several packets that are being pumped should be marked with the sequence number. Therefore, GBN sender required a buffer, and this buffer is also called as window, and it looks something like this. These green packets are those packets available in the window, available in the buffer of the GBN sender, these packets have received the acknowledgements, and from here till here, specifically, the packets are being sent, they are in the channel, but acknowledgements are yet to be received. And this is the packet which are in the queue and which is to be sent. And these are all the packets which have been dropped from the application layer. As this particular packet, they are named as base, and of course base and next sequence number are the parameters of GBN, and I think we can ignore this because we are not studying the protocol in its implementation viewpoint. Therefore we will just realize as to how GBN works. When this particular packet receives the acknowledgement, this packet will be admitted. Just recently arrived packet from the segment from the application layer will be admitted into this particular window size, and it is as if window moves in rightward direction. Therefore, the buffer of GBN sender is also called as moving window or sliding window protocol. And this is already ACK'd, unusable, not yet sent but not yet acknowledged, and they are not usable. GBN sender, the range of permissible sequence numbers for transmitted but not yet acknowledged packets can be viewed as a window of size n over the range of sequence numbers. As the protocol operates, this window slides forward over the sequence of number space. It is rather window doesn't slide, actually the packets are admitted. It is relative movement told that way. For this reason, n is often referred to as the window size and the GBN protocol itself as the sliding window protocol. In practice, a packet's sequence number is carried in a fixed length field. Of course, it is a 16-bit field, in the packet header. If k is the number of bits in the packet sequence number field, that is 16, the range of sequence numbers is thus 0 to 2 to the power of k. It should be 2 to the power of k minus 1. GBN has distinctive senders events as well as receivers events. We will go through what exactly sender will do and what are all the different phases the sender is going to experience. First one is invocation from above. That means application layer will trigger sending of the packets. The sender first checks to see if the window is full. Okay, upon the request from application layer to receive the part of the message that is being sent from the application layer, the sender first checks to see if the window is full. That is, whether there are n outstanding unacknowledged packets. If the window is not full, a packet is created and sent, and variables are appropriately updated. If the window is full, the sender simply returns the data back to the upper layer, an implicit indication that the window is full. Receipt of ACK. In this GBN protocol, an acknowledgement for a packet with sequence number n will be taken to be cumulative acknowledgement. It is called as cumulative acknowledgement because it indicates that all the packets up to the sequence number n has been correctly received by the receiver. Therefore, each and every acknowledgement received by the sender of GBN is also called as cumulative acknowledgement number. A timeout event will trigger a typical situation. The protocol's name Go-Back-N, in fact, is derived from the sender's behavior in the presence of lost or overly delayed packet. As in the stop and wait protocol, a timer will again be used to recover from the lost data or acknowledgement packets. If a timeout occurs, let us say if timeout occurs for packet number 4 and by the time packet number 8 is also sent, then packet number 4 to 8 will be retransmitted. That is packet number 4, 5, 6, 7, 8. All the 5 packets will be retransmitted or resent. Okay. If a timeout occurs, the sender resends all the packets that have been previously sent but that have not yet been acknowledged. Okay, this is the reason why Go-Back-N is so called. Go-Back-N receivers events are only 2 in number. The receiver's actions in GBN are also very simple. If a packet with a sequence number n is received correctly and it is in order, okay, then the receiver sends an ACK for the packet and delivers the data portion of the packet to the upper layer. A very important point to be observed over here is each and every packet will be sent to the application layer if and only if it is arriving in order, number 1, and it is not corrupted. If the packet is corrupted or if the packet is in order, out of order, then the acknowledgement for the previously received correct packet will be sent back. That is, corrupted packet or out of order packet, the receiver discards the packet and resends an acknowledgement for the most recently received in order packet. Note that since packets are delivered one at a time to the upper layer, if a packet k has been received and delivered, then all the packets with a sequence number lower than k have also been delivered to the application layer. And this is the timeline diagram showing the GBN action. Send packet 0, receive packet 0, send ACK. Send packet 1, receive packet 1. Send packet 2 gets lost in between. Packet 3 is also sent because packet's acknowledgement has not yet appeared. Then let us say packet 3 times out. Packet 2 times out. By the time several packets have been sent, okay, starting from packet 2 up to packet 5. See, packet 5 is also sent. By this point of time, packet 2 times out. Therefore, GBN, as the name itself would imply, will send packet number 2, packet number 3, and 4 and 5. Okay, this is n number of packets here, n equal to 4. Therefore, 4 packets are asked to go towards the receiver. Here at the receiver end, receive packet 2, deliver acknowledgement 2. Receive packet 3, deliver acknowledgement 3. Okay, and if it is a duplicate packet, it will be dropped. Okay, now selective repeat protocol is little more effective and efficient. Okay, and we will see that how exactly it is happening as far as selective repeat is concerned. The GBN protocol, as we have understood in the foregone discussion, allows the sender to potentially fill the pipeline with redundant packets, with the duplicate packets, and also accompanying acknowledgement packets, thus avoiding the channel utilization problems we noted with stop and wait protocol. In particular, when the window size and bandwidth delay product are both large, many packets be in the pipeline. That is, huge number of bits will be available in the pipeline for no reason, because these bits represent duplicate packets. A single packet error can thus cause GBN to retransmit a large number of packets, many unnecessarily. As the probability of channel errors increases, the pipeline can become filled with these unnecessary retransmissions. As the name suggests, selective repeat protocol avoid unnecessary retransmissions by having the sender retransmit only those packets that it suspects were received in error. So, like GBN protocol, SR sender will also have few events, and so also SR's receiver. As far as SR sender is concerned, one of the predominant event is data received from above, that is data received from application layer. When the SR sender receives data from application layer, it checks whether the available sequence number for the packet is really to be put in the window, depending on whether the window is empty or whether the window can accommodate this packet or not. If the window is full, it will be admitted, otherwise it will be resent to the application layer, similar to GBN. When a packet times out at the sender, timers are again used to protect against lost packets. However, each packet must now have its own logical timer, since only a single packet will be retransmitted in timeout. That means if a packet times out, then that particular packet will be retransmitted. And unlike GBN, where huge number of packets will be resent, okay, SR protocol will retransmit only one packet that times out for many reasons. ACK received. If an ACK is received by a sender, the SR sender marks that packet as having been received by the receiver, provided it is in the window. Then the window base is moved forward to the unacknowledged packet with the smallest sequence number. SR receiver's event, there is only one event, of course. Packet with sequence number is correctly received. The received packet falls within the receiver's window. SR will send an ACK. If the packet is not correctly received, it is buffered. Okay, the correctly received packets are buffered, and the packets that has not received in out of order fashion, or if the packet is corrupted, then the SR protocol will resend acknowledgement for the previously correctly received packet, because there is no concept of NAK. So this entire SR protocol is picturized in the form of a timeline diagram, SR in action. This is the window available at the sender. This is the window available at the receiver. Okay, 0, 1, 2, 3 are being sent. Packet 0 received. Okay, packet 0 acknowledgement is sent. Packet 1 is received, and packet acknowledgement for 1 is sent, and packet 2 lost in between. By the time, since packet 2 acknowledgement is yet to come, packet 3 is sent, packet 4 is sent, and they are all stored in the buffer. You can notice over here, and only thing that is to be available to be reached is packet number 2. Okay, packet number 2 times out over here, and only packet number 2 will be sent. Packet 2 will be received, packet 2, packet 3, packet 4 and packet 5 are delivered. Okay, so therefore the buffer at the receiver's point of SR protocol will have a waiting period, okay, for a packet which has been received out of order, or for a packet which has been received in a corrupted fashion, will be acknowledged with the previously correctly received packet. As soon as this packet arrives in a correct fashion or in the correct order, it will be admitted to the window, and number of packets which is equal to the window size of the receiver will be uploaded. That means it will be sent to the application layer. So in GBN protocol, only one packet which has been correctly received will be uploaded to the application layer. Here bunch of packets which are arranged in a sequential fashion will be uploaded to the application layer. So with this, we will come to the end of SR protocol and GBN protocol, and we will just recall salient differences between GBL protocol and SR protocol. Only sender has a buffer as far as GBN is concerned. Both sender and receiver have buffers. And single sliding window protocol, and this is double sliding window protocol because of the presence of the buffer at the receiver end also. Timeout causes retransmission of many packets. Timeout causes retransmission of the packet that is timed out. Okay, that packet is only selected and it will be sent. Therefore the name for SR protocol. ACKs received for out of order packets and corrupted packets also causes retransmission of many packets. Only the packet in problem is retransmitted. GBN protocol was found to fill the channel with duplicate packets and ACKs, while SR protocol made effective utilization of the channel. So my dear esteemed viewers, this completes GBN protocol and SR protocol. In the next tutorial, we will bring out other service details of TCP, like its header configuration, how exactly TCP finds out the timeout interval, and also how exactly TCP implements its flow control strategy. So with this, we have come to the end. Until we go for the next tutorial, it's bye. And if you have liked this video, kindly subscribe.